This puzzle is called My Poker Tell by Maxentius. I got it from the Discord Puzzle Archive on the CTC Community Discord. Let's take a look at the rules. So, we have the killer cage constraint. So, the digits in a cage add up to whatever digit is given. So, these 3 digits are going to add up to 6. These 4 digits are going to add up to 14. And so on. And digits cannot repeat in a cage. If that matters. Oh, there's some bigger cages here. So, no digits can repeat within this yellow highlighted area. So these 2 digits couldn't be the same, right? So that's pretty easy. Then we have anti-diagonal. So up to 3 different digits can appear on the given diagonal line. So we have this long diagonal here that can only be 3 different digits all the way along there. So if we go in 1, 2, 3, then we couldn't do 4 here, for example, because that would be 4 different. Okay. I think that's it. On the Discord message, it's rated 3 out of 5 difficulty. So if you want to give it a try, I'm going to put a link to the puzzle down below in the description. Yeah, and let's hop to it. So the first thing I see is there's some very constrained killer cages here. There's a 6 cage here. The only way to make 6 and 3 cells is 1, 2, 3. Then we have 2 7 cages, which there's only one way to do it, which is 1, 2, and 4. So we know that 1, 2, 4 is one of the numbers. Because we only have, so what's going to happen here, I guess I should explain that. What's going to happen here is we're going to have, let's say, 3 different digits here, and then it'll be the same 3 digits here and the same 3 digits here. So if we could figure out that, let's say it was a 1, then effectively 1 would be forced, or let's say it was 1, 2, 3, like in my example, let's say it was 1, 2, 3, then this would be a 1, 2, or 3, and we could try to use that in the killer cage. 15 can only be made in 2 ways, 6, 9, or 7, 8. And things are running a little dry here. I guess this cage, or this cell is a little constrained. We can use up to a 6 and a 9 cage, 1, 2, 3, 4, 5, or 6, but we have a 1, 2, and 4 looking in. That's probably not helpful. That's probably not a helpful thing to type in. Okay. So, I am thinking more about these cells. Because the pink cells will be the same in all 3 boxes. It will be the same 3 cells. But also, we need to fit, one second, let me count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah. So yellow and green here are 9 cell killer cages, which means they're going to have all 9 digits, 1 to 9, in there as well. So where do we fit pink? Yeah, where do we fit pink in the killer cages? Well, none of these can be them. So it's all going to be in, so the pink will show up in here, so it will not show up in the 26 or the 25. Can we do anything more restrictive than that? Because we don't know, like, which is which along this line, obviously. But once we do, like, whatever this cell is going to be incredibly restricted because it can't be here, 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 or any of these. Plus, yeah, so this cell is going to be up here, but it could be a 1, 2, or 3, or it could be whatever this digit is, and that would be fine. But this digit is also going to be ruled out from one of these 3 because of whatever position it is along here. Similarly, blue is going to be forced into one of these 2 cells in green because it can't be here, can't be here because it's already in the column, and it can't be here because it's already, like, literally next to it. So blue will be here. So blue and pink are both up here. That means that blue and pink are, one of them, or at least one of them, is a 1, 2, or a 3, which we sort of already knew. And blue and pink, similarly, blue is going to be restricted into yellow into one of these spots, which is going to put blue down here. And pink is going to be restricted into one of those spots, which is going to put it down here as well. But this cell, what color could we even make it? Black, whatever. That's actually really bad. Let's just do gray. Gray is going to be forced into here, but much less restricted. It can basically go anywhere in the green right there. But the gray also cannot be in this 26 cage or this 25 cage because it has to be in this part of yellow. Now, it could be the same. It could be that one of these is a 3. And so then the 3 couldn't be in here, so this would be a 3. But it's more likely that, let's say, blue is 2, and it's the 2 up here, and it's also the 2 over here. This is tricky. Can we do any maths? Maybe I need to get rid of the colors for a second. We can do some maths. So if we look at, yeah, we can sort of do something. So yellow here, let's do pink. And yellow. Let's do pink and yellow both. So if we add up pink and yellow, I guess we can't even. How do I want to color this? Let's do it. Let me figure out how I want to color it first, and then we'll start doing this. Okay, so we have pink. Pink equals 15 plus 25 plus 7 plus 7 equals, was that 45? Sorry, 47. So pink equals 47. And if we look at gray here, gray is 1 full row. Now that means that it has the digits 1 to 9 exactly once each, right? Because every row, column, and box has the digits 1 to 9 exactly once each. If you add up those digits, 1 plus 2 plus 3 plus 4 up to 9, you get 45. So gray equals 45. So if we subtract, if we take pink, whoops, not 45. If we do pink minus gray, we're going to have these minus this is going to be 2. 47 minus 45 equals 2. So this, effectively, this cell is 2 less than these two added up. Does that help at all? This could be, yeah, I don't know if that actually helps at all. I was going to say if this is small, but I guess this must be, no, this could be literally be a 1, couldn't it? Maybe this math thing was not helpful at all. Maybe there's something else I need to notice. No, 26 could be down to 2. Oh, okay, here's something. Okay, I think I figured out what I need to do. We'll forget that. We'll forget that. So let's look at this. We'll forget that for the moment at least. So we have gray here. Gray is 4 boxes, 4 full boxes. Let's actually put this back up. Gray is 4 full boxes. So 4 sets the digits 1 to 9. Gray is 4 sets. Well, we can remove 1 set here. We know this cage is 1 set of the digits 1 to 9. We can remove this cage. That's 1 set of the digits 1 to 9. So now gray is 2 sets. Equals 2 sets of 1 to 9. Which we said before, 1 set of the digits 1 to 9 is 45. So so gray equals 90. 2 times 45 equals 90. Whoops, 90. But we also have quite a bit of killer cages here, so we can add up some digits. Let's make these pink for the moment. So pink equals 26 plus 15 plus 15 plus 25. That's 55. That's 81. 30 plus 51 is 81. Yeah, 81. So we've said that pink. So again, we can do gray minus pink, which this time there's no like leftover cells, which is going to be better. If we delete pink and gray, the overlaps, we get, whoops, equals 9. That's actually incredibly restricted. How can we make 9 in 5 cells? Well, we can make these 3, 1, 2, 3, and now these 2 can be 1, 2. This is the absolute minimum. What does that add up to? Well, we have 6 plus 3 is 9. So if we fully minimize, we get the values. So then this will be a 3, because these all have to be the same, remember? This can't be a 4, and this is 1, 2, 3. This can't be a 3. Which means this is 1, 2, or 3 as well, because it's either going to be 1, 3, 5 or 1, 2, 6. Those are the only options for that 9 gauge. Yeah, so now we have the diagonal, and hopefully we can figure out a little bit more. Actually yeah, let's look at something else. So in yellow, we need the digit 3 once, because it's a 6 and it must be 1, 2, 3. We need 1 to 3 in yellow. Also, along this diagonal, we need a 3 up here in box 3. It can't be here, so it must be along here. So we need another 3. If we look at the first 2 rows here, each row is going to have the digit 3 once. So in the first 2 rows, we're going to have the digit 3 twice. Once in row 1, once in row 2. Well, we've already kind of reserved 1 into the yellow and reserved another one into pink. So how many 3s could be in gray? Well, 0. We've used one of them in yellow, one of them in pink. There's 2 total. That's 2 minus 2 is 0. So this can't be a 3. And also, where can we put a 3 in box 2? It must be down here. It's not as hugely important as I thought it was going to be. Yeah, I thought this was going to do something, but it does not seem to be doing anything. Okay. Yeah, 3 is not... Oh, yeah, 3 is not that wild of a digit. Okay, actually, what I was talking about before is actually going to be important here, I think. So, this was yellow. We need to put pink into yellow somewhere. Where can pink go? It can't go here, and it can't go along here. And also, it can't go along here because we put pink into this. Pink is in this column. So pink is going to be in here somewhere. So now where does pink go up here? Well, obviously it's going to be in one of those 2 cells. Now that doesn't seem too important, but let's look at blue now. Where does blue go in yellow? Again, blue can't go in these. And now blue can't go in here, so now we have blue up here. Could we put blue here? Could we put another 1 or 2 here? No, because we already used 1, 2, and 3, so this is going to be blue up here. Oh, you know what? I'm dumb, and this is a lot easier. We have a 3 looking up, so this is just not a 3. But that's what I was leading to. What is that? These have to be 1, 2 pair. But I think actually it is going to be effective on this side. So where does pink go in this yellow? It must go along here. Where does blue go? It must go along here. So we need our 1s and 2s to go down here in row 9. Now, where can we do it? Could we put a 1 or a 2 here? No, we've already used 1, 2, and 4 here. So that must mean this is just 1, 2, and this is a 4. So it wasn't totally useless. We came up with one thing from it. Then we need 4 in one of those 2 cells. Yeah, that seems reasonable. Okay, what can we do next? We need a 3 along here. That's fine. Oh, this 3 means this is not a 3, so this is a 3, which means this is 1, 5. This can't be a 1. Oh, so now we need 14 without a 1. That's going to be 2, 3, 4, 5. This can't be a 5. Oh, this 1 actually makes this a 2, 1. So that's just a 4. Now we have a 2 in here, means this can't be a 2. This 2 is going to make this a 2, 1. We need a 1 down here. That's not really worth typing in, I don't think. We already put the 4 over there somewhere. 3 along there. I don't know if there's any more information we can eke out here. What about these two? So we have a 15 cage. We already have a 3, so this needs to add to 12. It can't be 3, 9 because we would have to repeat the 3, so it's 4, 8, or 5, 7. Which means we can't have 7, 8 on this side. If we do 7, 8, then neither of these options are going to work. So it must be 6, 9 on this side. I think we might want to look at this cage. Not 100%, but I think that's where we need to look. 26. I'm looking at the options. Let me just copy that in here. Okay, so we can't have a 6 and a 9. That's going to be against the rules. Okay, that only removed one option. I thought that would remove more than one option. It also can't have a 2 and a 9, because 2 and 9 are both going to end up here. Because they can't be in here. So it can't have a 2 and a 9. And it can't have a 3 and a 9, because again, 3 and 9 are both ruled out from here. We can have at most one of 3 or 9. Oops. So we're going to have a 6 or a 9, and that'll end up there. We don't know which one it is, though. Then we need a 5 and an 8 in here. And then the last digit is going to be a 4 or a 7. And then this will be whichever one we don't use. Unfortunately, that doesn't help us. Oh, actually, we can put a 5 here. That's something. 5 and 5 puts a 5 there. But unfortunately, we can't quite... Oh, no, we can't quite figure this out. So 5 here rules a 5 out of here. If this can't be a 5, then this can't be a 7, because it has to add to 12. I guess this is a 12. This is whatever 12th pair we don't use here. So this is 4, 8, or 5, 7. This can't be a 5, so this can't be a 7. This can't be a 4. This can't be an 8. Okay, I don't know. Okay. Let me look at the rules again and see if I'm missing something. No, we finished the anti-diagonal. It's 1, 2, 3 all the way up. Digits cannot repeat in a cage. I think I've taken that into account. Oh, okay, so where do we put a 4 in box 1? It's somewhere in row 3. We don't know exactly where, but it's somewhere in row 3. So could this ever be a 3? Sorry, could this ever be a 4? If this was a 4, then there would be nowhere to put a 4 in box 1, so it can't be a 4. This is the 4. And this is just a lot of 6, 7, 8s, and 9s. I don't think 25 is going to... We know even less about this, and 25 is less restricted than 26, of course. So I don't think looking at the 25 is necessarily helpful. This digit, whatever this digit is going to end up being in the 26 cage, though. I don't know if that's helpful. Where can we put yellow in box 4? It can't be in the same killer cage, and it can't be in the same column, so it's going to be over here. But I mean, if it's 5, then we already knew 5 was going to be in there, and if it's 4, that does help. It does help quite a bit. But we don't know that it's 4. I don't think there's any way we can tell either way, unfortunately. Oh, what about this math I did way early on? Can I undo back to that? The math that ended up being wrong and not mattering? So it was pink minus gray. So these two digits were 2 more than this digit. So this digit is a 6. That I don't think that's helpful at all. This digit is a 6, 7, 8, or 9, which means this is a 3, 4, 5, or 6. Or wait, no, it needs to be 2 more. So it's a. If this was a 9, this would have to add up to 11. This can't be a 4, so this can't be a 6. That's something. So these two digits have to add up to 2 more than this, I believe. I'm not 100% sure on that math. I believe it works, but I'm actually not 100% sure that that works out that way. And I think I might be able to figure something out instead. Let's look at the 25 cage that I said we didn't need to look at. Let's do it in pairs instead. Okay, there we go. So these are the options for the 25 cage. It can't have... What can't it be? What can't it be here? Is there anything that it can't be? I'm trying to see any options here. I don't know if we actually can rule any of these options out. What if we do go with this? I'll have to walk through the logic again. It would have a 5, 6, or a 7, which I don't think rules anything out. Yeah, it doesn't rule anything out anyway. So what am I not looking at? Let's maybe highlight these again. So we need 1, 2, and 3 in here. In both yellow and green. These can't be 1, 2s, or 3s. So we need 1, 2, and 3 in here. This cell's gonna go over here. This 1 and 3 are gonna go over here. I definitely feel like I'm missing something. And even using this logic and making sure, like looking at this logic again and making sure I'm right, I don't see how it will really help immediately. So I think there's just something else that I'm missing here. Could it be writing in 6, 7, 8s, and 9s? Or coloring 6, 7, 8s, and 9s? I don't think that'll help. Okay, here's something. This is a set of the digits 1 to 9. And this is a set of the digits 1 to 9. If we remove the overlap, the yellow is the same as the green. It must be. So where can this 6, 9 go? It must go here. And these must be 4, 5, 7, 8. In fact, one of these must be the 8 because there must be an 8 in here. So this can't be an 8. And these two digits are the same. which must go in one of these two cells. But does that actually... This can't be a 4. And also, we can do the same thing over here, basically. Pink is the same as blue. And these two cells, again, must be the same. So pink, or sorry, so it can't have 1, 2, or 3. That's something, actually. That's huge. Since blue can't have 1, 2, or 3, pink also can't have 1, 2, or 3. So it's going to have a 4. Okay, that's the thing I need to realize. That is incredibly huge. Both times, actually, I've looked at, the left-hand side of the grid, when it was actually the right-hand side, or the bottom side of the grid that's the helpful thing. So we have to have a 4 in here, because we can't have a 1, 2, or 3. That's going to mean this can't be 4, 8. So we can remove 4 and 8. It's going to make this 5, 7, and this 4, 8, which is going to put a 4 in here, make this a 7, make this a 4. Because that's just the last spot for it. Okay, that's huge. This must be a 9, right? 9 plus 9 plus 8, yeah. So then this must be that 9. We can't have 7 in here. So in fact, we know... Yeah, that's weird. I was just doing some math in my head that we sort of could have done 26 plus 25 plus 6 equals 12 plus 45 in a very weird way. I don't think it would have ever been helpful because we already knew this was 12, but just sometimes geometry in a situation like this just kind of blows my mind. Okay, so we have what am I trying to say? We have a 4, 5, 8 triple here, so this can't be a 4, this is a 2. This is now a 3, so we can rule 3 out of a couple cells. Okay, so we don't know exactly what this is, do we? Oh, this can't be a 4 because we've already used the 4 down here. So this is a 5, 8. So we do know exactly what this is. This is a 4, 6, 7. So we know this down here is a 4, 6, 7, 8. And 7 is ruled out of most of those cells, so this can't be a 7. So this is the 7. This can't be a 4 or a 6, so this is an 8. Yeah, that's good. Oh, and same thing over here. This must be the 4. Okay, what do we... This can't be 9. Oh, this must be a 7 because we have 7s looking up. Let me get rid of the colors. Colors can make it so it's harder for me to scan. Sorry, one second, I have to call. Winter always dries out my throat. So 7's looking over here. This is a 7. This is a 6, 8, or a 9. Because all of these are 6, 8s, and 9s. 6, 8, 9. This is not a 9, so this is a 9. One of these is a 9, so this is not a 9. So one of these is a 9, so this is not a 9. And this is not an 8. Okay, 7, 7. Oh, where can 7 go in box? This box over here. It must be in one of these two. Where can 7 go over here? Can't be... Whoops, that was... Trying to draw a straight line here. 7 must go in the middle, which means this can't be a 7, which means this is the 7. And then this is the last 7. The last 7. Okay, this 4 looks down. This 4 looks over. Yes, I was doing a voice for saying the last 7 for whatever, or the last 7 for whatever reason. Felt like it needed a little bit of a voice, special voice. Okay, so this is a 6 and a 1, 1 and a 6. This can't be a 1, so this is the 6, this is the 1. We need 2, 3, and 6. This can't be a 6. This can't be a 3. Oh, this 1 is looking down, so this is a 2, 1. So this is the 2, this is a 3, this is a 6. This 2 is looking over, so this resolves that. This is the 2, that's the last spot in the box that it can go. We need a 3, not helpful. This can't be a 2, this must be the 2. This is a 5, this is the last thing in the column. This is a 3, 5, or an 8, so this is just a 3 or an 8. And it can't be an 8, so it's a 3. Yeah, there we go. Yeah, this 6 means this can't be a 6, but it also means this can't be a 6, and we need a 6 in this row. So this is a 6, this is an 8, which makes this a 9. This can't be a 9 then, and it can't be a 6, so it's 8. 6, 6, 8, 6, 8. For this column, we need a 5 and a 3. This one can't be a 3, so it's resolved like this. 1. This 3 is looking down. This is a 3. This is a... what is this? A 5. And to finish it off, we need an 8 and we need a 9. There we go. That was a tough puzzle. I don't know how my time is that quick, actually. It felt like I was stuck so much. I guess it was once you figured out the tricks of the puzzle, and there were a couple of them. Once you figured them out, you could make pretty quick work of, like, it wasn't... yeah, there was, like, what were the hard tricks? There was the... yeah, figuring out, like, using these 4 boxes, that was one trick, and then also realizing where these must go into the neighboring box. That must also have been... those were the 2 main tricks, but after that it was mostly pretty easy deductions, I feel like. Unless maybe I'm forgetting another hard step in there. But yeah, that was a lot of fun. That was very tricky. Definitely there was definitely a couple times in there where I was like, I don't know if I'm going to get through this. But then eventually spotted the next trick. So thank you, Maxentius. That was a very tricky but very fun puzzle. I think that was actually maybe even their first puzzle. Yeah, very first puzzle set. So very good job with that. Yeah, so thank you for the puzzle, and thank you all for watching.